Some careful diagrams are needed in this question, but to begin with, we've got L1 written like this, and I'm going to write it in vector form because that is going to get x, and y, and z in terms of a parameter. So we can say that because these are all equal, the parameter is going to be lambda, and then rearrange each one. I'm just going to show the first one. So we could rearrange x, so x is equal to lambda minus 5. And then we're well on our way to writing down the equation in vector form because r is then going to be minus 5. And then we've got a plus lambda and a 1 here. We can do the same with y. So times through by minus 3 and minus 4. So I'm going to get minus 4 here and a minus 3 here. And the same with z. It's going to give me a 5 here and a 3 here. Over time, you just learn to kind of do this quickly, but I've tried to kind of find the right balance of explaining it and getting there. So that means that x is, I've written it like this because I think it's quite useful, but x is now lambda minus 5. So what I can do is sub that in to here. I'm going to get 2 times lambda minus 5 plus 3, and then y is going to be minus 3 lambda minus 4. So minus 3 lambda minus 4, and then minus 2z, so the minus 2 5 lambda plus 3, and that is equal to 6. We can now solve to find lambda. That's going to be where they intersect. So 2 lambda minus 10 minus 9 lambda minus 12 minus 10 lambda minus 6 is equal to 6. Collect these up. That's going to give me minus 7 lambda from here, and then minus 10 lambda, so minus 17 lambda. And then minus 22 minus 6, that's minus 28. Add that on, I'm going to get 34. The lambda is equal to minus 2. And therefore, if I want the point of intersection, I can just sub it back into here. R is going to equal minus 5 minus 4, 3, plus minus 2, 6, minus 10. That's going to give minus 7, 2, minus 7 as a, sorry, I've gone from a vector and I've written it as a coordinate, but that is what we're interested in. Good. Now we're told that the line L2 is a reflection of the line L1 in the plane pi 1. Okay, let's sketch this out. Here's my plane. Two-dimensional plane pi 1. I've then got L1, which I'm just going to draw like this. I know it intersects at the minus 7, 2, minus 7 that I had before. So why don't I introduce an origin, and I know here to here, maybe I'll call the point of intersection capital Y. That is going to be minus 7, minus 2, sorry, minus 7, 2, minus 7. I also know the vector to get onto the line because we wrote it up here. The minus 5, minus 4, 3 gets us onto the line, and then that other one is the direction vector, which we're going along some multiple of lambda. So minus 5, minus 4, 3. Okay, that's a good start. That is L1. And L2 is a reflection. So remember when you have a reflection, you just get a mirror image on the other side. We're going to end up getting a line that looks a little bit like this. It's also going to intersect the plane at minus 7 to minus 7. Okay, there's one other piece of information I'm going to add before I then get into the solution process, and that is I've got the equation of the plane, and this can be written in a slightly different form. I'm going to bring it down. Okay, because an alternative version, I'm not going to go into loads of detail on this, is that it's r times a normal vector is equal to d. But the point is that we can rewrite it as, well, let me write it as r dotted with 2, 3, minus 2 equal to 6 in this case. And that means I have my normal vector n is going to be 2, 3, minus 2. Okay, so there's quite a lot going on here, but this is our setup. So I'm going to label this point here P. That is how I got onto the line. And then I'm going through the plane. Let me do this in a different color, actually. I'll do it in purple. Yeah, I'm going through the plane to get to the mirror image on the other side, which I'm going to call P dash. And that is how I want to get onto my line L2. Actually, I could get onto the line L2 at either Y or at P dash. But if I got P dash, I can work out the direction vector. This is our plan. So it's all about now finding where this line that I've just drawn intersects the plane. So that's X. Okay, so I know that Px is going to be some multiple of the normal vector. So I'm not going to call it lambda for the moment because I think there was a lambda in the answer. I'm going to call it r. Px is going to be r multiplied by the normal vector, 2, 3, minus 2. What that means is that Ox is going to be minus 5, minus 4, 3, plus r times 2, 3, minus 2. Sorry, some of my numbers are not coming out very well. That was meant to be a 3 there. And remember, X is actually in the plane, so I can do the same thing that I did before and work out the value of r where X is, essentially. So it's going to become 2 times 2r minus 5, that's my X, plus 3 times 3r minus 4, that's my Y. Sorry, minus 2 minus 2r plus 3, and that is equal to 6. Let's work out the value of r. 4r minus 10 plus 9r minus 12 plus 4r minus 6 is equal to 6. Add these up, I've got 13, 17r. Here I'm going to get minus 28, I'm going to get 34 again, so r is equal to 2. Brilliant. So I've now got X, but actually I've also got Px. Therefore, Px is going to equal 4, 6, minus 4. And from that, I can get OP dash. Because OP dash is going to be, I need to go from O to P. And then I actually need to go twice what Px is. This is a hard question, but if you've practiced this topic enough, and I'm assuming you're not seeing this for the first time or for a long time, if definitely do some more practice if you're struggling with any aspect of this. Okay, it will come together over time. So then it's twice that px. So yeah, let me just say again, I want to get from O to P dash. So what I'm doing is going from O to P, and I'm going from P to X, and then X to P dash. That's just twice PX. So it's going to be 2 lots of 4, 6 minus 4. And that is going to equal minus 5 plus 8 gives me 3, minus 4 plus 12 gives me 8, and 3 minus 8 gives me minus 5. 3 8 minus 5. Remember that was our OP dash. So let me just add that to my diagram. 3 8 minus 5. Okay, so now, I know I'm a bit all over the place here, but now if I want to find P dash Y, because remember that gives me a direction vector for L2, then it's going to equal OY, which we worked out because it was that minus 7, 2 minus 7, minus OP dash. So I'm going to be minusing that 3, 8, minus 5. So this equals minus 10, minus 6, minus 2. Now normally I would divide through by 2 to get just a different direction vector, but in the final answer, like what you can see, they've actually left it as 10, 6, 2. So we've got all the key information really. I might just write that, okay, then that means that yp dash, this is going to be the direction vector going in the opposite direction, is going to equal 10, 6, 2. I'm just trying to justify why I can ignore the negative. And therefore, r, right, we're basically there, so as long as we've shown enough working. So for L2, I'm going to get onto the line at y. Okay, you could get onto the line at p dash, but they've asked us to do a show that. So we're going to get onto the line at y. That's going to be minus 7, 2, minus 7. And then I'm going to be doing some multiple of the direction vector that I found, which gives me the 10, 6, 2. Okay, the good news is this was a show that question. So if you get there and you got that answer, you can be really happy. If you somehow slightly out, but you're kind of getting there, you've done all right. And you can now use this from now on in the rest of the question. Bad news is that it's not like the question gets loads easier from here on. So let's take a look at the next part. We're told that the plane pi2 contains the line L1 and L2. And we're asked to determine a vector equation for the line of intersection of pi1 and pi2. Okay, so if I'm going to try and sketch this out, well, the plane is going to be looking something like this and then extending. Um, but the key idea you need to get across is that, right, we know that we know that y and x are both in both planes, actually. It's definitely in the first plane because that's how we found them out by finding the values. And then because we know that like x is it's not on the line, but it's going to be in the same plane as the two lines, then what we're actually trying to find in this next part is the equation of this line here. So we just need to get onto the line at either x or y, and then we need to be going in the direction of xy or yx. So actually, it's not as bad as it might first look. So I could write down, I might just bring my whole diagram down here to continue to refer to. Okay, so we can say for this line here that r is going to equal minus 7 to minus 7 to get onto the line. You could alternatively have used the ox that we had before. Did I work out what that was? Yes. No, I didn't actually. But you could have substituted 2 into here. Then you get a slightly different vector. There's more than one answer because we can get onto the line in more than one place. So, but I'm going with this version. And then I need to work out, actually, I do need to work out what OX is, I've just realized, because then that's what I'll do for to get XY. Apologies. Yeah, I'm going to do that. Okay, so I need to put it into here when R is 2. Let me actually just bring this down. So I'm going to get minus 5 plus 4 gives minus 1. Minus 4 plus 6 gives me 2. And then 3 minus 4 gives me minus 1. So I'm saying that instead of using this one, we could have used this one. And then xy is going to be minus 7 to minus 7 minus that minus 1 to minus 1, which gives minus 6, 0, and minus 6. So I'm then there really with my line. I can have a new parameter and I could use minus 6, 0, minus 6, or I could use yx and use 6, 0, 6. Actually, we can do even better. We can divide through to make it 1, 0, 1. So as long as you've got some multiple of 1, 0, 1, you'll be okay here. And you're getting onto the line either at y or x, but this is how I'm going to leave it. I think this is a pretty nice way of writing down the answer. So that is our equation of sorry, not of L2, for the line of intersection between the two planes. We worked out that, yeah, the plane is going to go through, well, we kind of drew this rectangle using L2 and L1, realized that it's got to go through Y, this line. It's got to also go through X because that is in the plane of L1 and L2. So it must be, we just found the vector equation going through YX. Well done. Finally, we've got another plane, I3, with this equation. A and B are constants, and we're given that the planes form a sheaf, and we're asked to find A and B. Okay, so you now need to know what a sheaf is, and it's basically where, okay, I'm just going to draw it out. It's where three planes intersect, and there's just like a single line that is their kind of line of intersection. So it's a consistent system. So we're getting this kind of set up. We might have pi1 here, pi2 here, and then this one would be pi3. So we've got that line that we've just found that went through two of the planes, but actually it goes through all of them, which means we've got our r, which I'm now going to write just as -7 plus s, 2 and -7 plus s. That's just a different way of me writing what I had here. So that is the line. And of course, we've got the plane here, r dotted with 1, 1a, and that's equal to b. Now, we know some points. This is how I did this question. We actually know some points in pi3, so actually I can sub in. I don't, in fact, need that there. I know that we've got, what was it, -7 to -7 is on the line. And so is, we had that one before, where was it? It was OX. OX is also on the line. So OX was -1, 2, -1. I can sub them in. It must be that -7, 2, -7 dotted with 1, 1a is equal to b. And therefore, -7 plus 2, sorry, -7a is equal to b. So 7a plus b is equal to -5. And then we'll do the same with the other points. -1, 2, -1 dotted with 1, 1a is equal to b, which means -1 plus 2 minus a is equal to b. So a plus b is equal to 1. I'm going to subtract these, which will give me 6a equals -6. Therefore, a is equal to -1. Put that back into the second one. B is going to equal 2. So there is actually a slightly quicker way to do this question. I've realized now why I wrote the line down. Yeah, I wrote the line down when I did the question, then I went on this other path because I was like, I'm not quite sure what to do. But if I write it back as -7 to -7 plus s, oh, I can't fit it in, which is s times 101. Right, now remember we've got a normal vector here. That is a normal vector. And it must be that the normal vector from, say, pi3, it's going to be sort of coming out like that. That must be perpendicular to the direction vector of the line. Think about it. We've got a plane here. Actually, let me draw it in. Got a plane here. We've got a line going through it. The normal vector is going to be going like that. It's just a bit harder to see. So it must be that 1, 1a dotted with 1, 0, 1 is equal to 0. Because they're perpendicular, the dot product is 0. And that straight away gives us 1 plus a equals 0, so a is equal to minus 1. We could then use the minus 7, 2, minus 7, dot that with 1, 1, minus 1, and that will be minus 7 plus 2 plus 7, giving us 2 or b. I don't know, quite like how I did it, but I just wanted to mention that method because, yeah, it's a slightly quicker way to get to a, but my method of using 2 points was also valid. Okay. Ooh, good, tough. I mean, vectors for me is like one of the hardest topics on further maths, this core of further maths. Just dealing with these like things in 3 dimensions takes time. It's hard to visualize. It's definitely a lot of practice needed. The questions can vary significantly. This is a very specific question about reflecting the line in a plane. So look out for some more if you struggle with that aspect. And then there's always sort of stuff that comes up that you've maybe never seen before, bringing sheaths in, or you might have seen a sheath, but like dealing with this particular scenario, finding equations, like we've got 3 planes here, so it is just a case of practicing. But yeah, well done and thanks for watching.